Right. So someone was telling the checkpoint. Can you can just so repeat so exact understanding of the checkpoint, or if someone else, anyone.
Yeah, actually, checkpoint will move the data from buffer to data file, but lazy writer only flushes the data from pool to to the storage. In my opinion.
Okay. So you mentioned checkpoint will move. Sorry, checkpoint. What you mentioned, like move pages from the buffer pool
Yeah,
to the disk.
yeah, it will move the buffer. Readed. I mean, only the committed transaction to the whatever the committed or non-committed transactions. It just moves. It will make an entry in the log file.
Hmm.
But lazy writer will flushes the committed transactions to data file. But checkpoint will. This is my point of
Mhm.
view. I
No
don't know
issues.
whether.
No issues. No issues. Yeah. Good that you so came up with whatever points you thought. Like definitely. So anyone else?
For example, in log file, we can able to see a number of transactions like insert, update, whatever it is. Number of bulk operations will happen, right? We will call it a dirty page. Like whenever it is committed, then it will automatically write into data file like this. So checkpoint every 60 seconds will run, right? Like this.
Correct.
So automatically it will commit, and whenever it commits on it, then it will write to the data file like this.
Okay. Okay. Cool. So anyone else have any other thoughts? It's okay, like so whatever you thought, just wanted to understand a high level, so whether so either I should explain or not. So I just wanted to so ask, but I'll definitely explain if you have any other thoughts, or anyone else are thinking the same.
Yeah, actually, if any incomplete transaction, like there is no commit or rollback log record, we
Hmm,
can using that we can roll back using
correct.
the checkpoint. Yeah.
So how checkpoint would be helpful in rollback?
Actually, for any modification records, it's not flushed to the disk.
Hmm,
So in that time, we can able to roll back, right?
correct. But where that modifications will be written. So for example, let's say the transaction is not committed. It's a DML operation. It is not committed. So where the transaction will be written?
It's a buffer cache.
Buffer cache. Okay. But if you restart the SQL instance, the buffer cache will be cleared, right? So you will not have anything in the buffer cache. It is just a temporary area or workplace where you can keep the data for temporary purpose. If that is the case, everything will be gone. So you will not have anything, right?
Okay.
Yeah. So I'll just so give you a high level overview, right? For example, as I told you, so the modifications. For example, it is an update, whatever, like so DML operations, and we are modifying that. So if we modify, right? So if we do any modifications, what log manager does? So log manager, it will write the transaction log, whatever the transactions from the data from the log cache in the memory. So log cache to the transaction log file before we modify that data page, right? Before we modify the data page, right? Once this log manager return the transaction to the log file, then the buffer pool entry, like whatever pages in the buffer pool, will be modified, right? So if there is a checkpoint, but before checkpoint, yeah, whatever pages which are modified in the buffer pool, we call it as a dirty page, right? So what is dirty page? Dirty page is the page in the memory which is modified from last checkpoint, right? From last checkpoint, whatever modified pages in the buffer pool, we call it as a dirty page. Now, so whenever checkpoint happens, it does two things. One is it will write the log cache entries into the transaction log file. So it will write whatever pending log cache entries, it will be written to the transaction log file. First thing it will do that, right? It will write into the log cache, the log file, so that whenever there is a crash happens, so it can recover the transaction. Either the transaction is committed or uncommitted, it is secondary, but it will first write the transaction information into the transaction log file, right? That is first thing. Second thing, it will write whatever modified pages from the last checkpoint or whatever dirty pages we have in the buffer pool, it will be written to the database file, right? Checkpoint does two things. One is it will write the whatever we have in the log cache to the log file, transaction log file, before writing these modified pages to the data file, right? So checkpoint does, it will write into the transaction log file, and it will flushes the data pages, dirty pages from buffer pool to the data file with respect to the transaction is committed or uncommitted. So we don't care like whether the transaction is committed or uncommitted, what will happen? So it will flush all modified pages from buffer pool to the data file. Also before that, it will write into the transaction log file whatever the transaction information, right? So that whenever crash happens, whenever there is a crash or restart of the SQL instance, it will scan the transaction log file to identify from where it has to recover. That is where we have recovery phases, right? So we have how many phases? We have four recovery phases. One is, so discovery phase, analysis phase, redo, and undo, right? So in discovery phase, so I'll just give you a high level overview. What is that? You must be knowing that. So, but yeah, today update, that is what update query is. So we have some time to discuss few points. So I am discussing some internals, right? So discovery phase, it will read through complete log file to identify the VLFs which has to be recovered, right? In discovery phase. Analysis phase, it will so identify the last checkpoint. From there it will so it will create a recovery point, right? So it will create internally dirty page table and active transaction table to recover your transaction. So in the dirty page table, what it contains, so what data or what pages we need to roll forward, that is writing into the data file. So in active transaction table, whatever transactions which are not committed at the time of crash, so those will be rolled back, right? So where the checkpoint information will be written. So how the checkpoint information will be written? There are two places the checkpoint information will be written. One is transaction log file. Second one is database boot page, right? So I'm not going into pages and all, but we have a main database page, that is boot page, where the checkpoint information will be written to the boot page. Whenever database is started, so it will scan the boot page and identify the checkpoint LSN. From there, it will determine from where the data has to be, so recovered. The transaction has to be recovered. In simple words, checkpoint is a writing data page, a dirty pages from buffer pool to the disk. Also writing transaction information from log cache to the data log file, log cache to the log file, right? So when this page we said like so it is dirty, right? When this place will be clean, so the place will be clean, or so when there is a checkpoint, if the checkpoint happens, the page will be flushed to the data file, right? Then the page, we call it as a clean page. It is not no more dirty because whatever modifications it is there in the data file. So it consider only dirty when this page is different than the data file page, right? For example, data file page is 100, and you copy this page, or buffer manager copies this page 100 here, and you does some modifications and you modify it to 110. This is called dirty, right? So we modified some data. This is called dirty. And as soon as you checkpoint happens, this page will be flushed to the data file. So you will have this 110 here as well and 110 here as well. If both are same, then we don't we never call this as a dirty, because the checkpoint is written the page from the buffer pool to the disk. So it is, in a simple words, checkpoint is just copy the pages, copy. So don't use this word, but so just I'm telling you for the sake of simplicity. So you just consider this as copying pages, modified pages from buffer pool to the disk. So what is Legendreader? So what does Legendreader do? So if there is any so memory pressures, right? If there is any memory pressure, so it will check so some algorithm it will follow. So that is LRU algorithm, least recently used algorithm. It will flushes or remove. So in other words, you can consider this as a cut and paste into the data file, right? Checkpoint is just a copying pages from buffer pool to the disk. Legendreader, it will cut pages from the buffer pool. That is the reason it will clear some memory. If there is a Legendreader so happens, so it will remove the pages from the buffer pool so that the memory will be clear and it will be flashed to the data file, right? It depends on least recently used. For example, my page is so 10 minutes or 10 seconds, and that page is 1 second and which is currently in use, right? So it will be used, it will be removed this 10 seconds so whenever it was last used, right? If it is not recently used, then this will be removed from the buffer pool and returned to the database file. So is it clear how that works? So checkpoint and Legendreader. So any questions so far, right? So the update query, so that happens, and so any questions on update or anything on checkpoint or Legendreader?
In the Legendreader, can you explain also this?
Sure. Yeah, sure. So we will talk more so when we talk about the memory so but I'll just explain Legendreader. So checkpoint clear. Checkpoint, I'll just give you again high level overview. Checkpoint is writing into the transaction log whenever checkpoint happens. So there are different types of checkpoints, right? So if you are not aware, just read through the books online. So we have different types of checkpoint. One is automatic checkpoint, manual checkpoint, indirect checkpoint, and indirect checkpoint and auto. Yeah, so there are two things: automatic checkpoint and auto checkpoint. Auto checkpoint is every 60 seconds. Automatic checkpoint is based on recovery interval. Recovery interval, it will keep on executing the checkpoint so internally, right? We can define that sp underscore configure, so that will define, like so how frequently we need to execute, we need the checkpoint to be run, right? So indirect checkpoint is target recovery time, that is also sp underscore configure. Well, I'll just show you if so you must be aware, but FGURG sp underscore configure, that is the advanced, sorry, so that is the advanced option. So recovery interval, this is the automatic checkpoint, and we should have target recovery time is the okay. So I think this is option. Target recovery time is by default it is 60 for from 2016 and onwards. You can So let's have 80. Right. Set target recovery time. So database configuration. So we can set the so indirect checkpoint for individual databases, right? So this is indirect checkpoint for individual databases. This is at the instance level, automatic checkpoint. So it happens frequently to flush the data pages to the disk, right? That is checkpoint. So lazy writer. So what exactly it does? Let's say there is a memory pressure. So memory pressure, so I will discuss more in memory, but for now understand that there is a memory required for SQL Server, or memory required, so let me consider this simple term. Max server memory, right? So you consider max server memory as 1 GB. Let's consider, right? So then you have a database size. DB size is 2 GB. Let's consider, right? So you have a 2 GB database and you have max server memory is 1 GB, right? So you are doing some, so huge operation, either select, update, whatever it is you are doing. So you need to read almost all the pages. Let's say, for example, you want to read 1.5 GB data pages, right? So you need 1.5 GB data pages. So you have just read, so 1 GB data, 1 GB, and it is almost reached. The max memory is reached because you have 1 GB, right? So that is reached. What about remaining 500 MB? 500 MB data is left over. So we cannot read because the max server memory limit is reached. Then what will happen? SQL internally detects there is a memory required for this 500 MB pages to be placed in the memory. Then the lazy writer SQL memory manager. So internally it will ask all its memory, so clerk. So I'll not go into that, but SQL Server internally ask everyone to reduce their memory. So buffer pool will be monitored by the lazy writer. So buffer pool will be monitored by the lazy writer. So it invokes and it checks if the memory limit is reached. So it is a continuous operation. It is not kind of, so it will suddenly wake up and it checks. It is not that way. It will check continuously whether the memory limit is reached or not. Whatever max error memory we set is reached or not. So this lazy writer, it keeps on checking for max error memory limit, and it detects that max error memory is reached. Once it is reached, it will cut down the pages. What does it mean by cut down the pages? Whatever pages which are not recently used, LRU, right? Least recently used. Whatever pages which are not recently used, those pages will be removed from the buffer pool and write into the data file. So these pages will be removed and write into the data file. So if it is not recently used, and these will be removed from the buffer pool to the data file, so that it will clear some memory. Let's say, for example, 200 MB, it is cleared. 200 MB, it is cleared. If it is cleared 200 MB, then we can place 200 MB pages here, right? So if it is reached, again it checks if there is any other pages I can remove which are not recently used. Then it will remove those pages and it will be moved to the data file. So though the pages are in use, if it is needed, then it will be removed from the buffer pool and it will be right into the data file. Right, it will keep on doing that if the pages are if the pages are currently in use. Let's say, for example, these pages are in use, it will be flushed to the data file. When these pages are need, it will be read again from the data file to the buffer pool. So it is kind of removing that. So if the pages are in use, maybe we have an option to increase the max server memory so that these pages will not be removed and it will not be read from the disk, right? So Legendreader is a process of removing the pages from buffer pool to clear some memory in the buffer pool, to see clear some memory for SQL Server to store some more pages or to release memory to the OS. Let's say another example is OS. Operating system needs some additional memory. So additional memory, if it needs, we need to remove from the SQL Server, right? So SQL Server is using most of the memory. Then it will be removed and it will be, so the memory will be reduced and it will be released to the operating system. So that is, we will talk more, so how that works, like max server memory, min server memory, and let's say for example OS needs memory. If OS needs memory, why my SQL Server should remove memory from the disk, from the memory, from the buffer pool, right? I don't want SQL to be released. So we do have some options. We will not so release our SQL memory. That option I will discuss more in detail. So is it clear, like Legendreader and checkpoint? Is it clear?
Question.
Cool.
Yes.
Yeah, cool. Right. So I think I am done with the update statements. So one more, so I will just, thought of telling that. So you must have heard delayed durability, right? So can someone heard that? I mean, so did you guys heard delayed durability, or what is delayed durability? What is durability? Let's consider this as a so interactive session so that you will have so better understanding of internals and how that works. But maybe it is useful for you to attend interviews as well. Yeah, someone.
Yeah,
Oh.
it's one of the type and ACID properties.
Hmm.
So simple example, you are recording the session.
Hmm.
Even if you need, we can see it from the recording session. That's a simple example for the durability.
But how that is helpful for SQL Server?
SQL Server, for example, if the data has been lost as a power cut, something like that, then data will be retrieved from, but the data will not be flushed from the data file or transaction file.
Okay. Yeah, so whatever you said, that is seems to be correct. But yeah, so for just so high level, what is durability? As you mentioned, like it is a last property of acid atomicity, consistency, isolation, and durability. So durability is once the transaction is committed, so it will be available even if the system is crashed or database is crashed, or so even if there is any restart happen, anything, that transaction will not be so whatever committed transaction will not loss, right? So that is what a main purpose of durability is. Once the transaction is committed, then the transaction or whatever committed transaction will not be lost even if there is any system crash, right? So what, like how the logs will be flushed? So log cache will be flushed. So I'll just give you a overview. Right. Let's say consider this log cache. So what is log cache? Whatever transactions we are writing into the, I mean, whatever, if we do any DML operations, it will be writing that information to the log file, log cache first. So log cache. So from log cache, it will be written to the transaction log file. That is your LDF file, right? So whatever modifications we are doing, so it will be written to the transaction, it will be written to the log cache first, which is there in the memory, and a separate log writer thread. So don't worry, we will discuss about the threads. For now, understand this is one of the worker, one of the thread that it is writing log cache to the log file, right? So while when this log cache data will be written to the log file, I told you two scenarios. So one is when the transaction is committed. So if the transaction is committed, then this will be written log cache in whatever size with respect to the size of the log cache, it will be written to the log file. Second, when the buffer in log cache, when the size of the buffer size in the log cache is reached, let's say buffer cache is 4 KB. 4 KB. If it is 4 KB reached with respect to the transaction is committed or not committed, it will be written to the log file, the whole buffer, complete buffer, right? So it will be written to the transaction log file. Let's take a scenario. We are using temp transactions or small so transactions. It is frequently committed. For example, let's say insert. So insert. So you are doing some insert, like huge inserts, right? It is immediately commit. So if it is immediately commit, what will happen? It is keep on writing into the transaction log file. As soon as this transaction is committed, it is keep on writing into the transaction log file. So what will happen? So the log file is very busy, right? So it is keep on writing into the transaction log file as soon as the transaction is committed. If it is a small transaction, for example, let's say insert into test values 1 comma ABC. Let's say this is a small transaction. So as soon as this is committed, I'm not going into the um, the transaction, the transaction types. So we have multiple transaction types, right? Implicit transaction, auto commit transaction, and explicit transaction. I'm not going into that. So this is a auto commit transaction. So it is, so auto commit transaction. As soon as the transaction is completed, the transaction will be committed. If this is committed, what will happen? It will write immediately to the log file. This is committed, it will write immediately to the log file. It is committed, it will write immediately to the log file. If that is the case, every time we are trying to write and so doing every insert or every modification, we are keep on writing into the log file, the LDF location or LDF file is very busy, and you will see some delay in performance, right? So you will see some performance issues. Instead of that, I don't want every transaction to be written to the transaction log file immediately as soon as it is committed. Instead, I will write once the limit is reached. Let's say it is 4 KB. Once this is reached, then only I should write into the transaction log file. Then you'll have to enable delay durability. So delay durability option, what it does, it will delay writing into the transaction log file. It will be delayed writing into the transaction log file, right? So instead of writing each and every transaction once it is committed, it will wait for this 4 KB, so whatever size is reached, then the transaction or log buffer will be written to the log file, right? So that is how the delayed durability works, right? So this is, so out of this so topic, but just wanted to let you know so that you understand in a better way how the transactions information will be written to the transaction log file. So we are basically so delaying a committed information written to the transaction log file, right? So this will reduce the load onto the LDF file, right? So you must have heard, so wait up as write log, right? Write log wait type. So write log write type is this. Whenever you are writing into the transaction log file, this is the wait type it will be waiting on. If you see high number of write log wait types, so this is one of the reason that you are keep on writing into the transaction log file as soon as the commit is happen. right? So just to avoid this, maybe you can consider the delayed durability, or you'll have to understand why we are keep on writing into the transaction log file. But we will discuss more detail about wait types when we talk about the wait types we have on major wait types in SQL Server. Right? Hope this helpful. So any questions on any of the process like yesterday's or today's or whatever points we discussed, like checkpoint leads you write a delayed durability or anything? So I will stop here. So if you have any questions, we will discuss, and so we will continue next class. I will let you know, so either tomorrow or so either tomorrow or Monday. But yeah, so you have any questions, you can reach out, you can ask me here now.
Yeah, Chandu, so for how the trial will work on optimization here for the update?
So update query, so the trivial plan, so optimization, so if it is a simple query, so that is the same thing, like so even it is a select query or update query, so it will check internally, like so either um it needs how many tables we need to retrieve to update the table, update the data, right? So it can be a single table or it can be multiple table, but it will check what is needs to be updated, how many records we are going to update, and how many how many pages we need to read to update that. So mostly I never see that update is a trivial. Mostly it is a select is a trivial, but so even update also can, optimizer will choose whether it go for so full optimization or trivial, so based on that. But definitely it will go for so my understanding is it will go for trivial if you are using any indexes. Let's say we have indexes and it has to scan the index to update some data, right? So how update works, it has to read pages and then it identifies which page needs to be updated. If we have a index on that page, so then it will either go for seek or scan based on the index we have, then the update will be updated, like whatever data we will be, it will be updated to that particular page. If we don't have an index, so we need just so we will be reading the complete table or complete so all the pages, and it will be updating. So if you are not using any of the indexes, it might go for a trivial plan, or if it needs to read multiple tables to get the data to be updated, then it go for full optimization. If we have a indexes, or it like say for example, as I told you, right? For example, let's say the update query, the cost is, how would I say? Yeah, cost is more than the cost threshold for parallelism. So because those terminology I have not explained, so I was not, so more comfort in talking. But let's say consider cost threshold for parallelism set to 50 or 20, or by default it will be 5. If update query is reached that limit, then it go for full optimization. Then it go for parallel execution, parallel so query and all, multiple threads and executing that, full optimization, right? So it so derives multiple level of optimization to go, either it is a trivial or full optimization. So it based on various factors, like so indexes, cost of the operator, cost of the query, and so how many tables and how many pages we are reading, how much data we are retrieving. So we will be doing that. Let's see. um let's see if I get any. Sorry. See, so even though it is a small, so it is going for multiple queries, right? So for example, let's say you are doing something and you are executing this, right? So okay, where is that? Reconfigure configuration. Okay. business entity equal to 200. Something is not updating, but yeah. So if you do, for example, let's say estimated plan, right? So even though it is a small table, so it read through multiple joins and all to get the data, right? So because it has to read, so multiple, though in a single table, it has to read through multiple, so pages and multiple columns and all. So that is the reason it is going for loop join and all. So it has to read indexes and all. So based on this, it is going for optimization. See here, this is, even though it is a small simple select query, it is going for update, right? If you use this, so this is also going for full optimization. So I never see that. That is the reason I never see that update query is going for trivial plan. So mostly select query is going for trivial plan. So update query, mostly it is going for so full optimization, because it has to do so two things. One is it has to read the page. Select query, it has to how update works, and basically, so it will read the data, then it will delete the data, then it will insert, right? So selecting, deleting, and inserting, right? That is how the update works internally, but that we will not discuss more. But that is the reason we don't see the update queries going for trivial plan, right? Is that clear? Did I answer your question?
Yes, Chandru.
Okay, cool. So any questions?
Hello, hi Chandu.
Yeah.
For the small question, Chandu.
Yeah.
When 10 transactions are updating, so the 10 transactions first will be done in buffer cache, right?
Correct.
I think
Log
buffer
cache.
cache. After buffer cache, it will goes to the log file.
Correct.
In log file, information is recorded, or that same transaction also data also will be placed.
So
The 10 transactions.
transactional, yeah. So transactional log file. So you will not have the exact, so data or something. So you will have the transaction information, like either it is, either update or insert. So that information will be written in the transaction log file. So you will not
Only
have
information, no data will be there in the log file.
No.
Only information will be there.
Correct.
And after committing the data, it will flush to the data file.
Once the transaction is committed, so still it will write into the transaction log file. At the same time, the pages will be written to the data file once the transaction checkpoint happens, not commit. So if you commit, so the page will not be written to the data file. It is still there in the buffer pool. Once the checkpoint happens, that is the only point where data will be written to the data file. Pages will be written to the data file.
Yeah, that the data won't be there in the log file. Only information will
data
be there.
will be there in the log file. No, so data will be there in the log file until and unless you truncate the log file. So it is still available. Yeah. So whatever transactions we are doing, so it's still available in the VLFs or transaction log file. So only will not be available if you truncate the VLFs. When this will be truncated, then if it is full backup, full recovery, then you'll have to take a log backup, or if it is simple recovery, then there is a limit like 70% or 80%, then it will be truncated the transaction log file.
Yeah.
But if the transaction is committed, then only you can truncate that, right?
So only complete only, then will truncate. That means the data is available in buffer cache as well as the log file. Both we are having the data.